So look at this. The before going to the laser part, we must know the full form. Okay, because this is the acronym only. So we need to go for the full form. That is, I hope you people are aware also. So it is light amplification by stimulation of radiation. Okay, and I have highlighted the starting point, LASER. So now it is very clear. So you have to note it down properly, because many times what people are doing is they are changing the word. They are saying, instead of by, they are writing off. Instead of off, they are writing by. So the moment you change it, the meaning is going to be changed completely. So keep in mind, because you may have to give some online test also, and during that time it may be asking, it may ask many times. So you just have to be proper on the words. Okay, so it is laser. Now coming to the next thing, history part. Okay, so as I said, if you have gone through the book, then you have to first read to the starting chapter, and always you will find in our lectures that whatever the new topic we are going to start, we are seeing the history part, so that will give you the brief idea. Okay, what has happened till now, and what may be the possible things which can be covered in the future. Okay, so it's a good to start with the history. So you look at very carefully. So Towns and their colleagues, they have created the first microwave devices. Okay, microwave amplifier device. So before talking about this laser part, already Maser is there in the existence in 1954. Okay, and what may be the full form of Maser? It is similar to the laser, only instead of light, now this M represent for microwave. Otherwise, everything is almost same. Okay, so Maser was already there in 1954. Towns and their colleagues, they have prepared this device, okay, in which they have amplified the microwave signal. Now after certain time, Swallow and Towns, okay, these two scientists, Towns is again same, so they have extended this principle, Maser principle, to the light part. Okay, as I said, that's why in the tutorial we have discussed the importance of electromagnetic spectrum, because that is the base now. So when I say microwave part is extended to the visible light, so you must know where the microwave and the visible part is there in the electromagnetic spectrum, and is it possible to move to the one range to the another, or it may be slightly difficult, right? So if you are having the idea of electromagnetic system completely, then these things are going to be very easy to understand for you people. Okay, someone is asking for the history part. So history is sometimes, okay, because these are the popular scientists, and the discovery is also very famous, because everything is depending on that discovery itself. So sometimes it may be asking, but it depends on the examiner, no one knows, right? So these two scientists have extended whatever the working principle they have for the microwave devices, they have extended to the light things, light in the sense visible range basically of electromagnetic spectrum, in 1958. So you see the year wise difference. Okay, in 1954 they have Maser, then 1958 they have laser light. Now they have just given the principle, they have just given the idea that okay, laser light can also be generated if we are working on the similar principle which Maser light Maser devices was working. So then another scientist who took up this principle, though it is given by Swallow and Towns, but it was used by Maiman. Okay, the full name is T.H. Maiman. So Maiman, sorry, T.H. Maiman, and you can find the same thing in the book also. So T.H. Maiman has constructed the first successful as well as working laser using a crystal which we are knowing as a ruby crystal. And if you look at the color, then color is a red color crystal, basically red or kind of pink color crystal, someone say. So that ruby crystal, with the help of ruby crystal, they have created the first successful device, okay, in 1960. Now important thing over here is, you see this crystal is in solid form. Okay, so many a times why I'm focusing on the content in depth, because in MCQ type of exam, these small details may come. Okay, so I'm giving the idea from that point of view also. So this laser devices using this ruby crystal, ruby basically is a solid form, crystal is in solid form. So sometimes this particular laser is also known as ruby laser because of ruby crystal. Apart from ruby laser, this is also known as solid state laser because this crystal is in solid form. So people are also saying solid state laser. Okay, then there is one more name given to this particular laser system, that is 3-level laser system. Okay, why we are calling it as a 3-level laser system, we'll discuss in coming slides, but you just keep in mind that the same laser, it has multiple names: ruby laser, solid state laser, or 3-level system, a 3-level laser system. So like that there are many, but you see it is in 1960. And again, see, whenever something is happening in the science world, so people are more and more working towards it to find out some new things, new events, new phenomena. So during the same time, again, you see, after a few months only, so another scientist, name is Ali Javan, and their teammates. So basically students, him mostly. So they have created another laser which is working on the gas. In the first, you see, that was on working on the principle of solid material. Now it has taken the material as a gas. Okay, so successful gas laser they have created, and within few months of ruby laser. Okay, and that name they have provided helium neon laser. Why? Because whenever we talk about the gas, helium and neons are the inert gases. So he used the inert gas helium and neon to prepare the laser. Okay, and that's why, because he used helium neon, we are saying as a helium neon laser. I hope I'm not giving you more history, more content, but whatever the required for you people to know, that I'm putting it over here. That's it. Otherwise, I suggest you that you go through the book. Okay, after preface or something, they have the proper history. Okay, and that time you can see year wise year development, even up to maybe around 2000 or 2010 something, whenever the book published, up to that time they have covered the history properly. So I hope it's a good idea if you just look at once. Now the second thing, you see, it's laser versus loser. Okay, now we know already the full form of laser. Now you see that is another thing, that is loser, LOSER. Now what happened actually is, if you look at, I am going again, if you look at the full form of laser, it is saying that light amplification by stimulated emission of radiation, right? Here it is the amplify word is there, but in general, in practical life, if you see, then light is getting not amplified. Amplified is there, of course, but the actual process which is happening inside is oscillating the signal. Okay, so if you look at, if your signal is oscillating between some medium, then for that we are writing this capital O. So if you can see that over here, this one, let me put it some highlighter. You see this. Okay, I hope it is visible. So you see this capital O, this O stands for oscillation. Okay, so because actual process is this only, but let's see the reason why they are saying still as a laser only. So you look at here, as I told, basically your signal is amplifying, but the process is oscillation. Now other is thing, how this part is going, how your system is working as an oscillator, how this process will take place inside the system. So basically you see, some part of the output energy we are feeding back to the system again. So basically it's a kind of feedback system which we are following in the laser system. And whenever we talk about the feedback part, there has to keep in mind always, there has to be two kind of feedback: negative feedback and the positive feedback. Okay, and I believe that instead of negative feedback, we must focus always on the positive feedback. I am just saying nothing to do with this, but in general, so the same thing in this laser system, what people are doing is they are using the positive feedback instead of negative one. Okay, so maybe in the next lecture also we'll discuss more about what can be the positive feedback. I mean, how we can define positive feedback and how we are defining as negative feedback. What are the difference between these two? It in all detail we'll cover, right? So don't worry. At this moment, I will say we are using the positive feedback to the system so that this process is going on inside the laser system. Okay. Now, how to obtain this feedback system? So for this you required an active medium. Okay, so all these components, as I said, oscillator, active medium, all we are going to cover in the detail, but here I am going to describe you the difference between laser and loser. Fine. So now coming to this, so what happens is, when they are developing this technology, this journey of laser, so people thought to change the name and keeping it to the loser. Okay, because actual process is the oscillation one. So if you go for that, then it is LOSER. But what happened in that case? if you apply for further funding, because your technique is still in the primary stage, okay, and if you are going further, yeah, I will clear everyone doubts. Just let me complete this slide, then we'll take the doubt. So what happen if you go with this name, okay, and this is at the starting stage, and then people may make it fun for that, right? Oh, it's a loser project, they are going to apply or something, right? If you want to do some startup and you do some name, funny name, right? So obviously at the beginning the people will make a lot of fun with that, and sometimes it may be rejected also with the name. So it to avoid all kind of possibilities or something, so what they decided to retain the same name which was decided earlier, that is laser. Otherwise the actual process is going to be the oscillation one inside the laser system. So just keep in mind, because many times the numericals or the problems are coming on this these things. Okay, now if someone is having doubt, so the good way is we'll discuss one slide and then we'll take the doubts. So I think that will perfectly solve the purpose of this online teaching. Okay, so if someone is having doubt, someone is already having, so you please unmute yourself and ask.
Hello, sir.
Yeah, please.
Sir, as for its production, it resonates in optical resonator. That's why it is called oscillation.
Yes, because your signal is traveling back and forth from one point to the another point.
Between two mirrors.
Yes,
Okay.
between two mirrors.
Okay.
We'll cover it. Don't worry, we'll cover it. That part also we are going to cover. Not today, maybe, then maybe in the next lecture somewhere.
And so just because of first instant of the name loser, it was getting rejected, right?
Yeah, because people are, see, it is the natural tendency of a human being. They, instead of focusing on the positive side, they are first focusing on the negative aspect. Okay, so they are not looking for the actual, like what technology they have developed something, but they will make fun of it, right? It is general, it is human being
Yeah.
nature,
Thank
nothing
you.
else. So that's it. Okay, so if it is clear, no doubt, then let me move forward. Some of the useful terms which we are going to use in this, okay, that is atomic systems. So it has discrete energy levels. Whenever I say, because these are the terms which we are going to use very frequently during the lecture of laser systems, yeah, laser physics. So atomic system, whenever I say, that means it must have discrete energy levels. I hope you are able to understand with the word discrete and continuous, right? You have studied up to 12th that energy levels either are discrete or continuous. Discrete in the sense you can easily count it, easily you can identify the difference between two levels. So that's why we are saying as a discrete energy levels. Continuous in the sense, like there are so many energy levels nearby each other, and then it may be very difficult to identify as a discrete level. So it looks like a continuous spectrum. Okay, so that's what we are saying as a continuous and discrete. But whenever I talk about the atomic system, that means I'm talking about the energy levels which are having difference in between. So we are knowing as a discrete energy levels. Okay, energy levels, again, you see, now how to define this energy level. So basically energy levels, that means in which the orbits are, whatever the orbits are there, they have certain amount of energy. That's why based on that we are saying as the energy levels. And you people are already have gone through the syllabus of up to 11 12th, that we may assign the energy to the each level. Okay, and this is also one fact that at the ground level the energy is lowest. As soon as we are moving to the higher level, the energy is going to be increased. But in that case, of course, the scenario is going to be completely different. We'll see what are the different changes if you compare with the ground level to the higher level or to the excited level. Okay, so I hope these words are clear to you people. Now coming to this population. So whenever I use this word, that means I'm talking about the number of atoms, or somewhere people are calling it as a particles also, because it all depends on the kind of material you are using. Because as we have seen earlier, in case of ruby laser we are having the solid state, in case of gas laser we are having the gaseous state. Okay, so depending on the medium, these number of atoms or molecules or particles, this word will change. But in general, either you can describe it as a number of atoms, or you can simply call it as a number of particles also. There is no harm in that. So whenever I talk about the population, that means number of atoms or number of particles per unit volume I'm talking. Okay, so you just keep in mind, because many a times when we go further, we are simply skipping this per unit volume because it is understand by default that number of atoms, whenever we are talking about number of atoms, it has to be per unit volume only. Okay, so you just keep in mind whenever we say number of atoms, that means I am talking about per unit volume also. Okay, in a particular energy state, and either you can call it as an energy state or energy level, both are same, but different authors are using different ones. Someone is saying energy state, someone is saying energy levels, but both are same, nothing to worry with that. If this is clear, then let me move forward. This is what you know already, and I was talking about little bit to this part also. You see the nucleus, and you see the orbits, number of orbits, 1, 2, 3, 4, defining with the n. And on the right hand side, you see the energy scale. And see, many times, as I said in the tutorial or in maybe the case of lecture, that how you are going to represent the thing, that matters a lot. So here also you see I have just plotted some simple lines, okay, for n equal to 1, 2, 3, 4, 5, 6, 7, and go on. But important thing is the energy scale which I placed over there. As you can see the arrow also, so it clearly indicates that as soon as I go to the higher levels, and you people are already knowing that there are infinite energy levels, right? So the moment you go to the maximum one, the energy will be more and more for that. And if you look at to the ground level, which is n equal to 1, so the energy will be lowest in that case. So the pictorial way is very easy to understand everything, where the energy resides. For higher level, what may be the energy level, and for lower level, what may be the possible energies. Okay, so this is already you have studied, so I'm not going to take much time into that. Yeah, now the important thing is coming. See, again, I'm going to use the same word, electromagnetic spectrum. Okay, already we have seen. Now there are 7 components we know very well. So these 7 components, right? Some of the component wave is going to interact with the atom. Then what may happen? Okay, so basically laser light is all depends how your electromagnetic wave, a particular component of wave, electromagnetic spectrum, how that is going to interact with your atomic system. Okay, when I say atomic system, that means it must have atoms as well as some energy levels also, as I discussed in the last slide. Atomic systems means it has to be some energy levels, it has some energy levels, inside that some atoms will be there. So how your electromagnetic wave, be it let's say visible light, be it microwave, be it infrared, okay, how that is going to interact with the atoms which is there in a system, okay, in a material. So there are 3 possible ways. The one is people are saying as stimulated absorption, the second is spontaneous emission, and the third is stimulated emission, right? Now if someone can see clear difference, there is only one process of absorbing of the light, but for emission there are 2 processes. Okay, so one can argue that spontaneous absorption also has to be there in this, right? But the thing is, let's take an example. If I say you people that okay, you joined to my class at 11:10, okay, and you have joined all, and I will not say a single word during this 50-minute time. Are you going to study by your own? It's quite difficult. Of course, we are living in the real world where the probability of everything is possible, right? Already we have seen that nothing is 0%. Some probability may be there, something, right? So maybe 1% or 2% students are there which can go through the content by their own, but majority of the students are like they are not going to do anything if no one is going to teach or no one is going to suggest what to do next. Okay, so that's the same stuff over here. Spontaneous absorption is not going to happen. यानी जो absorb करने वाली चीज है वो अपने आप it will not happen automatically. Okay, so that's why see you just keep in mind spontaneous means happening by its own. Okay, automatic kind of thing. Stimulated kind is like some kind of force basically. Okay, why I'm saying you these 2 words, because to give you the proper idea what exactly the meaning of spontaneous and the meaning of stimulated. Spontaneous means going to happen by its own, अपने आप होने वाली चीज. Stimulated is like someone is forcing you. Okay, so that process we are knowing as a stimulated one. Clear? So I told you that the spontaneous absorption cannot be possible. The probability is less. So that's why we are neglecting over here. So only three possible outcomes will be there: stimulated absorption, spontaneous emission, and stimulated emission part. Now just wanted to ask one thing: how many of you have gone through the content which is already there on the YouTube? Have anyone seen the content? Anyone? Yeah, please unmute yourself and say something if you have gone through the content. Have you gone through? Yes.
Yes,
Okay.
sir.
Okay. And have you got the complete meaning which I want to convey into the YouTube video or something? Because the purpose of YouTube video is just to provide you the content, because and I told you in the beginning also, maybe in the last lecture, that whatever the things we have covered over there in just 5 to 10 minutes, the whole lecture we have to cover that part. Okay, so that's the real difference in explaining the things in a proper manner. Fine. So if you have gone through, you know the idea about these three process. But to understand in more detail, in more proper way, let's take an example. Okay, I hope you all people will like that example, because I believe that examples can be really worth to understand the physics. Okay, and that will make you more interesting to learn. Fine. So let me ask you few things, and you people have to respond properly. So you can unmute yourself, okay, anytime, and you have to respond it. Now let me ask you one thing from you people. Okay. Simple पूछता हूँ, so that you will get the. Are you comfortable with Hindi? Because that particular example will be more prompt in.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Oh, okay,
Yes, sir.
okay, fine. So one simple thing I want to ask: गुस्सा आता है? गुस्सा, anger?
हाँ
Yes, sir.
हाँ
Yes, sir.
आता है. Perfect. So
हाँ सर
no one can deny कि no, मुझे कभी गुस्सा नहीं आता, right? I don't have any anger or something. So all are agree that at some moment of time they are getting angered. गुस्सा आता है. Fine. Now coming to the next step. See, look at to the approach also which I am following. We are following the systematic approach again. First thing, गुस्सा आता है, yes or no? So you people said yes. Almost 100% or let's say 99% said yes, गुस्सा आता है. The coming next thing is, अपने आप आता है या कोई दिलाता है?
कोई दिलाता है
वो दिलाता है
है ना?
दिलाता है।
अपने आप कोई ऐसा someone who said that I got angered by my own, बिना कुछ करे मुझे गुस्सा आ जाता है?
No, sir.
नहीं आता, राइट? दैट इज व्हाट आई सेड. स्पॉन्टेनियस के चांस है ही नहीं आपके पास, राइट? तो स्पॉन्टेनियस गुस्सा पॉसिबल ही नहीं है. ओके, यानी कि दैट मींस गुस्सा आता है, दैट इज फाइन, यू एक्सेप्टेड. बट खुद से नहीं आता, दैट आल्सो यू एक्सेप्टेड, यानी स्पॉन्टेनियस है ही नहीं. कोई दिलाता है, किसी की गलती से आता है. समवन इज फोर्सिंग यू, राइट? समवन इज फोर्सिंग यू. So and then only you got angered. Are you clear? Are you getting the message?
सर ऐसे भी
Sir.
explain कर सकते हैं ना इसको?
Yes, sir.
यस सर
Yes, sir.
Related process.
Sir,
Okay. Yes.
sir, as we know कि every atom in the universe want minimum energy. हायर एनर्जी से लोअर एनर्जी में जाना प्रेफर करता है. अब
हाँ.
सर खुद ही आपने बताया स्पॉन्टेनियस मतलब अपने आप कोई
हाँ.
भी एटम फोटोन कंज्यूम करके हायर स्टेट में जाएगा ही कि एक्साइटेड स्टेट में, वैसे भी समझ सकते हैं
हाँ,
ना
तो,
सर?
तो वही तो बोल रहा हूँ, अपने आप नहीं जाएगा ना. वही तो मैंने बताया. डाउन होने में सी एक्साइटेड, ऑलरेडी जो एक्साइटेड है, दैट कैन गो टू द लोअर लेवल, राइट? क्योंकि वो सी वॉट एवर द थिंग्स विच इज देयर इन द एक्साइटेड स्टेट, दैट कैन नॉट बी परमानेंट. What we are talking about is the first stage, right? गुस्सा आने वाला, गुस्सा डाउन होने वाला कैसा लगे, that we'll discuss. You just wait for 2 minutes, okay? I will clear you out. So this process is clear. First one,
Yes, sir.
Absorbing process,
Yes,
right?
sir. Yes, sir.
Yes, sir.
Someone is forcing you to getting absorb, यानी गुस्सा आ जाए या something whatever. And what happens if you are angered? गुस्सा आया तो क्या हुआ?
निकाल
आपका
दिया.
टेम्परेचर बढ़ा,
Yes.
राइट? आई मीन गुस्सा आता है तो गुस्सा बढ़ता है ना, एकदम दिखता है अलग ही, राइट? छोड़ दिया सब कुछ भी, समथिंग फाइन. नाउ व्हाट हैपेंस, किसी ने आपको गुस्सा दिलाया, देन हाउ मच टाइम यू विल मेक इट मेंटेन? कितने टाइम तक? 1 hour, 2 hour, 1 day, 2 day, 1 year, 1 month?
Depends on person.
Okay, someone is saying depends. So let's start with the maximum limit. Let's start with the 1 year. 1 year? Is it possible?
No.
No, sir.
No, sir.
Of course, no. Possible ही नहीं है. Let's bring it down. 1 month. In certain cases,
No,
Yes,
sir.
sir.
certain cases, of course, the answer is no. But in certain cases, people may think, okay, 1 month, fine. Then still you can get lower. 1 day,
Yes.
Yes, sir.
1 day is possible, right?
Yes, sir.
Fine. Now what happens next? After passing the 1 day,
नॉर्मल हो जाता है सब.
हुआ ना? Normal हुआ?
Yes, sir.
Yes.
Now that is the important thing. Are you coming to the normal level by your own, or someone is again forcing you to come down to the normal level?
अपने आप आ जाते हैं.
खुद से आ गए.
खुद से आ गए तो spontaneous second category fulfill कर रहे हो.
Yes, sir.
Are you getting the message? If you are cooling down by your own, okay, after certain time interval, that means you are belonging to the spontaneous emission category. आपने आप से कंट्रोल कर लिया. But at the same time, आपका गुस्सा कंट्रोल ही नहीं हो रहा है, but your friends are helping you to cool down. That is the case of stimulated. बोलते हैं ना हम लोग, कुछ लड़ाई हो रही है ना, कंट्रोल नहीं हो रहा है, 2-4 फ्रेंड आते हैं अपने समझाने के लिए.
Yes, sir.
They are consoling you. नहीं यार, हो जा, सब खत्म कर दे, छोड़ दे, whatever. That means they are forcing you again. That is the category of third one, stimulated emission, जिसमें आपको कूल डाउन तो होना है, यानी आपको एक्साइटेड स्टेट से लोअर स्टेट पे, ग्राउंड स्टेट पे आना तो है, but that will be done by someone else. Okay, and if you are doing by your own, then it's spontaneous. So I hope these three processes are clear to you. If these three are clear na, then your laser physics is complete. Okay, because the whole syllabus of laser physics is depending on these three processes only. That's it. So if this is clear, I hope this example is worth to explain the concept of these three processes. Is it okay?
First, stimulated एक बार और clear कर देंगे.
Yeah, it is like, see the purpose is, if I need to do something, right, if I need to get laser light, okay, so laser light is generally emitting from whenever the transition is happening from higher level to the lower level. Okay, so to reach to the higher level, we required some energy to provide to the ground state particle so that it can absorb it and reach to the upper level. So that is what we are doing in the stimulated absorption process, because I need to generate laser light, and laser light can be generated when the transition is happening from higher level to the lower level. But how to reach to the higher level? You required some energy to reach that level. Okay, so you provide extra energy, you provide, or you force the particle to get extra energy from some source and get excited and reach to the upper level. So that's what the process is, the first process, stimulated absorbing process. Now it is clear?
Yes, sir. Sir,
someone is forcing you to accept the energy. Okay, because of that, after accepting the energy, you will reach to the higher state. Yeah, please.
सर अगर लोअर स्टेट में आकर उसको स्टेबिलिटी मिलती है एटम को, तो फिर स्पॉन्टेनियस रेयरली क्यों होता है?
स्पॉन्टेनियस कौन सा, एमिशन वाला?
हाँ.
No, it is not rare. It is happening frequently. And other thing is you cannot control it also. See, no one knows in a particular atomic system, no one knows at what time the spontaneous emission will happen. It is happening, no doubt. You cannot say it is very rare. It is happening. But the moment it is going to happen, you don't know. Because it's completely random. But in case of stimulated, you people have the control. Okay, at this moment, I need to bring it down. So I will apply that much amount of force, energy, and I will bring it down. So that is control level, but spontaneous process is not at all control level. We don't have any choice of that. And even we don't know the time also, at what time it will emit.